Hi guys, welcome back. Today we are going to do lesson 2-1, graphing two variable equations. We are going to be in the Springboard book, so starting on page 17 through page 20. You will need a pencil and probably your calculator. So let's get started on page 17. So we are going to be graphing to find solutions. We are going to write equations in two variables to represent relationships between quantities, and then graph those equations on coordinate axes with labels and scales. All right, so that being said, go ahead and read through this with me, okay? Follow along. It says here, Roy recently won a trivia contest. The prize was a 5-day trip to New York City, including a round-trip airplane ticket and $3,000 in cash. The money will pay the cost of hotel rooms, meals, and entertainment and incidentals. To prepare for his trip, Roy gathered this information. A hotel room in New York City costs $310 per night, and the trip includes staying 5 nights. A taxi between New York City and LaGuardia Airport will cost $45 each way. Roy must set aside the cash required to pay for his hotel room and for taxi service to and from the airport. Once he has done this, Roy can begin to make plans to enjoy the city with his remaining prize funds. All right, so think about this. How much money does he need to set aside? All right. Number 1 says, how much money will Roy have available to spend on performances, meals, and any other expenses that might arise after paying for his hotel and taxis? So first thing we need to do is look back up here, and it says the hotel costs $310 per night, and he has to be there 5 nights. So let's go ahead and multiply this. 5 nights times $310 a night, that sounds pretty pricey, is going to be $1,550 spent on his hotel. All right, but that's not all. He also needs to check out his taxi prices. So the taxi will cost $45, and that's each way. So to his hotel and then home. So we are going to do 2 times 45, which is going to give us another $90 for his taxi trips to and from the airport. Okay, so let's go ahead and add those two prices together to give us a total of $1,640 that he will spend on his hotel and transportation. Now, here's the thing. It's asking here, how much money will Roy have available? So it's not asking how much he's going to spend, it's asking how much he's going to have available. So we need to take that original price that he won, $3,000, and subtract the $1,640 for a final answer of $1,360 is what he will have in spending money. Cool. All right. Next up, during his trip to New York City, Roy wants to spend only his winnings from the contest. He wants to focus on his 2 favorite pastimes, attending theater or musical performances, and dining in restaurants. After surfing the web, Roy determines the following facts. On average, a ticket to a performance in New York City costs $100. This is important. And he will spend on average $40 per meal. Okay, cool. Keep all of these pieces of information with you moving forward. All right. So Roy wants to know how the purchase of each ticket affects his available money. fill in the table below. So right now we're just focusing on the theater tickets or the musical tickets that he's going to purchase. And we know that on average, those cost $100. So what I'd like for you to do is begin filling out this table. So go ahead and pause the video to fill out the table. Be careful when you get right here because there's a little skip in numbers. Okay, so be careful in that section there. Alrighty, so hopefully you paused the video and your table should look like this when you're done. So really all you were doing is subtracting $100 for each number of tickets that he purchased. So if you bought one, subtract 100, subtract 100, subtract 100, and so on and so forth. You had to be a little bit careful when you got to between 5 and 8 where it skips a little bit there. Okay. All right, then I would like you to pause the video and try graphing this information. So just plot the points from the table. All right, so hopefully you paused and you were able to graph, and now here is what your graph should look like. All right, and the question I have for you guys is, these points in the graph were not connected. Do you think we should connect the points here? Okay, and the answer is no, because this is what's called discrete data. And unfortunately, Roy is not going to be able to buy a half of a ticket, so we cannot connect a line through there because that would not be true. Okay? All right. What patterns do you notice here? Well, it seems to me that it is linear. And the reason for this is because there's a constant rate of change. That rate is always going down by $100 that he spends on a ticket. Okay. 4 says, explain how you determine the values for 8, 10, and 13. I'm going to let you go ahead and explain that on your own. Okay. Number 5 then says, and maybe your answer from number 4 will help you to come up with this, but it's asking us to write a function m of t that represents the amount of money that Roy has left after purchasing t tickets. So let's go ahead and say m of t is equivalent to the spending money that Roy has after his hotel and travel, of course. But each time we are subtracting $100 per ticket. So minus 100t. Okay. And that right there should be your function. Your little math tip over here says that a function is a relationship between two quantities in which each input has exactly one output. So the input would be the number of tickets, and the output would be the amount of money Roy will have left. All right, awesome. Let's keep moving. Use mathematical terminology to explain what negative 100 and 1360 each represent in your function in item 5. Well, the negative 100 is going to represent your slope. And we talked about this a little bit already. So that's going to be slope. Bear with my drawing today. Sorry about it. And then this 1360 is going to be the y-intercept, which makes sense, right? Because the negative 100 is the constant rate of change, and the 1360 is the starting point, or how much money he has. Okay. All right. Moving right along to number 7. Now Roy wonders how his meal cost will affect his spending money. So basically now we're trying to think about the meals and not the ticket prices. So it says write a function d of m that represents the amount of money Roy has left after purchasing m number of meals. Okay, well this is really similar to what we just did. D of m equals, again, we're pretending as if right now he hasn't bought any tickets. This is a completely separate problem we're thinking about now. So he still has the same amount of money, spending money, and we're going to subtract this time. Instead of $100, the meals on average are going to cost $40. So 1360 minus 40m. Okay. All right, so go ahead and either create a table or graph this as best as you know how. Be careful with the how this is counting, okay? So it's counting by 5s down on the M axis here, okay? So go ahead and pause the video and graph that yourself. All right, hopefully you paused. And here we go. There's our graph. And then number 8 says, what kind of function is d of m? And again, this one is linear. Okay, it's asking for what is the rate of change. And remember, the rate of change is just the same thing as your slope. Okay, so be careful with that. So in this case, our slope was negative 40. Okay, and then last but not least, number 10 says, are all the values for m on your graph valid in this situation, given that m represents the number of meals that Roy can buy? Explain. So